So this was a pop quiz which was related to exercise, electricity, and magnetism. The pop quiz one related to electricity and magnetism. Uh, First, what is meant by magnetic field? You have to learn these definitions, the standard definition. What is the meaning of a magnetic field? Magnetic field is a region in which the magnetic poles can experience force, or magnetic material can experience force. So it is a region in which the magnetic materials can experience force. We call that as a magnetic field. Then what is the direction of a magnetic field? How we define the direction of a magnetic field? The direction of a magnetic field is actually a direction of force on North Pole. Like which side the North Pole experience the force, that is refers to a direction of a magnetic field. That's why, like if we have a magnet, say we have a magnet, the two magnetic poles are there, north and south. So we draw the magnetic field lines out from north and into south. What is the reason why we draw out from north and into south? Because if I place a north pole, it will move away. If I place a north pole near the south pole, it will move towards. That's why the direction of a magnetic field is always out from north and it is into south. This is a standard about the direction of a magnet. Same thing, if they ask what is the direction of an electric field, so direction of electric field is a direction in which the positive charges experience the force. So region around in which magnetic material experience force we call magnetic field, and the direction of a magnetic field is actually a direction of force on the North Pole. Is it clear? Question one, part A and two, A1 and 2. Figure 8.1 shows a negatively charged metal sphere, and you have to draw the electric field lines. So when we draw the electric field lines, we always, for a positive, it is out, and for a negative, it is in. So when we show the electric field lines, so we have to draw arrows which are pointing in. The distance between the field lines shows the strength of electric field. So near the sphere, the field lines are closer. As you can see here, they are closer to each other. It means stronger electric field. But as we move away from it, the electric fields start to decrease. Now, MCQs related to voltage and electromotive force or EMF. The question is, which produce an electromotive force or EMF? EMF for electromotive force, it is work done on unit charge to move the charge around a closed circuit. So what produce EMF? So a battery or a cell produces EMF. That's why option A is the right answer for this. Four lamps are there. Each are labeled 240. In which circuit do all four lamps have the normal brightness? Means they all receive 240. Remember, when lamps are connected in parallel, the voltage will be same, but when they're connected in series, the voltage will divide among them. So this 240 volt supply is in parallel to this lamp, so it will receive 240 volts. But these three lamps are connected in series. So the total 240 will divide between them. So this will be 80 volts, this will be 80 volts, this will be 80 volts. So it cannot be A because we want all to receive 240. Then for B, these four lamps are connected in series. So if we have a 240 volt supply, this will be 60, 60, 60 and 60. So they all, because they are connected in series, whenever components are connected in series, the voltage will divide. If they are connected in parallel, the voltage will be same. So this is 240 and they are all connected in parallel. So they all receive the same voltage, 240 volts. And here 240 volt supply, the two lamps are in parallel. So this will receive 240, this will receive 240. But these two are connected in series. The 240 will divide between them. So it will be 120 and 120. So question is, in which circuit do all four lamps have the normal brightness? Because when the lamps are labeled 240, so for a normal brightness, they all need 240. That's why C is the right answer. Is it clear, this one? Question 3. Next is question 4. Which electrical quantity is defined in terms of, if the question was, yeah, that's, if the question was four lamps, each label 60. So in which circuit do all four lamps have the same brightness? In that case, B should be the answer because they all receive 60 volts, so they all will have the same bright, like normal brightness. Here, each lamp labeled 240. So for a normal brightness, each lamp required 242 volts. In question 4, which electrical quantity is defined in terms of energy supplied in driving a charge around a closed circuit? So what we call, if you want to supply energy to the charge, if you want to do work done on the charge, then it will be EMF, electromotive force. But if it is work done by the charge, like if it was how much energy is transferred by 1 coulomb of a charge when it is moving through the component, then it will be a potential difference or PD. But which electrical quantity is defined in terms of energy supplied in driving or moving a charge in a closed circuit? That's why this is refers to an electromotive force or EMF. The EMF of a rechargeable battery is 6 volt. What does it mean? It means 6 joules of energy is needed to move 1 coulomb of a charge. So 6 joules of energy is needed to move 1 coulomb of a charge. So which option explain the idea of electromotive force or EMF? Option A, 6 joules is the maximum energy of a battery provided in 1 second. No. Like voltage means how much energy is provided to 1 coulomb of a charge. In option B, 6 joule is the total energy that battery can provide before it can be recharged. No, it's like how much energy is given to 1 coulomb of a charge. So 6 joule of energy is provided by the battery to driving or moving a charge of 1 coulomb around a closed circuit. So C should be the right answer. Why not D? 6 joules of energy is provided by the battery to drive 1 ampere. No, it's not about ampere because the voltage is how much energy is used to derive 1 coulomb. EMF is how much energy is used to derive 1 coulomb of a charge. Like if the EMF was 10 volts, what does it mean? It means 10 joules of energy is needed to derive 1 coulomb of a charge. Is it clear? Question 5. So electromotive force or EMF, how much energy is needed to move one charge, one coulomb of a charge? A cell has an EMF of 1.5. So if the cell is having a EMF or electromotive force of 1.5, what does it mean? It means that 1.5 joules of energy is supplied to one coulomb of a charge to move in a closed circuit. So how much energy is supplied to one coulomb of a charge to move? So when we check the option, the cell convert 1 joule of energy to derive 1.5 coulomb. That's wrong. The cell convert 1.5 joules of energy to derive 1 coulomb of a charge. So when we check option B, the cell convert 1.5 joules of energy when deriving 1 coulomb of a charge around a closed circuit. So B should be the right answer. Why not C? The cell convert 1.5 joules energy per second. The voltage is not related to time, so this statement is not at all related here. It should not be refers to time. If it is joules per second, then it will become power. So it is not related to time. The cell convert 1.5 watt. It's not related to power as well. It's by the EMF, electromotive force, is actually a relation between the energy and the charge. How much energy is given to one coulomb of a charge to move it around a closed circuit? That is known as EMF or electromotive force. That's why B is the right answer for this. In question 7, a circuit contains a cell of electromotive force 2 volts. We have an ammeter and we have a voltmeter. We know when the components are connected in series, they will have the same current but different voltage. And when components are connected in parallel, they will have the same voltage but different currents. So first, when we talk about the current, a current of 2 ampere, current is a flow of the charges, like how many charges are moving every second. So 2 charges are moving every second. Out of 2 charges, 0.5 is moving from here. So how much current will flow from here? If the total was 2 ampere, so this will be 1.5 ampere. So the reading on the P should be 1.5 ampere. So P should be 1.5. Then when we talk about the voltage is divided in series. So when we talk about the voltage, we don't bother about the current here. We ignore this ammeter. This ammeter we ignore because we are talking about current now. We are talking about voltage. So if this was a circuit, this is a circuit and we are talking about voltage, the maximum is 2 volts. So out of 2, if 1.5 is here, how much voltage will be here? 1.5, and what voltage will be here? 1.5. Why? Because voltage in series, it divide like these two parallel are in series with a single. So if the total is 2 volts, out of 2 volts, if 0.5 volts is here, like 0.5 joules is used by the charges here. So remaining 1.5 they will use across each of them. So what is the reading on this voltmeter? The reading on this voltmeter will be 1.5. So the reading on the voltmeter will be 1.5 and reading on the ammeter is also 1.5. So for this one question, A should be the right answer. Is it clear, this one? Question 7. In question 8, again, it's a similar question about the concept of electromotive force or EMF. Which statement define EMF of a cell? So EMF of the cell is basically, it's not about the current. So A and B are totally wrong. It's energy supplied or energy When a chemical energy converted into electrical energy, it is the energy given to a one coulomb of a charge to move around a closed circuit. So that matches with option C. The energy supplied by the cell or a battery to derive a one coulomb of a charge around a closed circuit. So this was a pop quiz one which was related to electricity and magnetism.